This screencast is about the processes that operate in glacial environments. It's so important that you understand what these processes are, because when we go on to look at the landforms in the next lesson or two, you will need to refer back to these processes that have helped to create those landforms. So the first one we're going to look at is something called freeze-thaw weathering, and the diagram here shows us the processes, the three steps here of what causes freeze-thaw weathering. Now it's sometimes called frost shattering, and it involves the action of water as it freezes and thaws in a crack or hole in the rock. It's a common process and operates wherever there is plenty of water and where the temperatures fluctuate repeatedly above and below the freezing point. As you can see on this first diagram up here, during the daytime, water collects in these cracks within the rock. Then at night time, due to the temperature falling, it ends up freezing, and when water freezes it can expand by up to 9%. Obviously if it's expanding it's getting bigger, so up to 9% bigger. If the water is in a confined space or a small space, that expansion is going to create stress on the rock around it, widening any cracks that already exist. So as you can see here, the little red arrows, is this water here is turning into ice, it's grown bigger and it's pushing against that rock around it. That's going to cause that crack to become bigger. When the temperature rises again, so during the next day, the temperature rises, the ice begins to thaw, so in other words melt. The water seeps deeper into the rock, so any cracks and stuff the water can get even further into now because they've been widened by the ice. And after repeated cycles of freezing and thawing and freezing and thawing, fragments of rock may become detached, as you can see in this diagram, and fall to the foot of the slope in what we call scree. Now as you can see on this photograph here, we have a scree slope here. So these rocks are all little bits of rock that have been broken off up here on the top of the mountainside. Freeze-thaw weathering's operated up here, and the bits of rock that have fallen off have ended up at the base of the slope, and we call it a scree slope. The angular rock fragments produced by freeze-thaw weathering are vital tools for glacial erosion. What happens is these little bits of rock end up at the base of the glacier, as you can see here. So the blue is the glacier, this is the arrow showing the direction of movement, this is the rock, and the little bits of rock that have been produced by freeze-thaw weathering at the base of the ice and are used in the process of abrasion. Now abrasion has a sandpaper effect caused by the weight of the ice scouring the valley floor and sides using that angular rock material trapped underneath, so as you can see here. In the same way that sandpaper would smooth wood, abrasion results in a smooth and often shiny rock surface. Scratches caused by large rocks beneath the ice can often be seen, and these are called striations. So it wears away the rock. You can leave this rock here very shiny, but what happens is you get large scratches. If it's a very large bit of rock, a large scratch, and what we call that is a striation. The second process is plucking. And as you can see, when meltwater beneath the glacier freezes, it bonds the glacier to the base of the rocky surface below, rather like glue. So what will happen down here is that there have been some meltwater, so where the ice is melted, that refreezes against this rock here, a bit like glue, and then as the glacier moves, as the glacier is moving over, it's just plucking bits of rock away. It's like extracting loose teeth. So as you can see here, the ice is moving and these bits of rock here just getting plucked away from the surface. So we have abrasion where it smooths that land, and you have plucking where you get left with kind of jagged edges because of the fact that it's been plucked away, torn away from the rock. In the last screencast we learned about how glaciers advance and retreat, but we're going to look at here in terms of how glaciers actually move, what causes them to move. Now this photograph here shows us the French Alps, and in areas like this the melting ice in the summer produces a great deal of meltwater, so the ice is melting in the summer. This water helps to lubricate the glacier, enabling it to slide downhill. Now this type of movement is called basal slip, because it's happening at the base of the glacier. So you can't see here, here's the glacier coming down, and at the bottom of that glacier there'll be meltwater that's causing that glacier to move, known as basal slip. Now this basal slip can occur quite suddenly, cause sudden movements of a glacier. What you can also see though, up here in what we call a corrie eventually, at the top of the mountains, is what's known as rotational slip. Now, in these hollows, high up on the valley sides, this movement will be more curved. So it kind of curves around, so it's not just kind of underneath in a straight line. This movement is curved as it moves out of that corrie. The third way that glaciers move, or the third process that causes glaciers to move, is something called internal deformation. Now this causes the glaciers to move slowly downhill, and this is when in winter the glacier is frozen to the rocky surface, as we saw kind of with the plucking process. The sheer weight of the ice and the influence of gravity cause individual ice crystals to deform in a plastic-like way, and this causes the glacier to move very slowly. Now, rock fragments resulting from freeze-thaw weathering and those that have been eroded by the ice are transported by the glacier, which acts like a giant conveyor belt. This sediment, which is called moraine, and you can see here this diagram, this little bit kind of here, you can see a dark bit here, that is the moraine. That's eroded material that's being transported by the ice. But we'll look in future lessons about the different types of moraine and the different positions of the moraine, as I say, in a later lesson. The final thing we're going to talk about in this screencast is about deposition. Now, most deposition occurs when the ice melts. So we talked about the zone of ablation, where the ice is melting, it can't carry the material anymore, so it drops it. In other words, deposits it. As most melting occurs at the snout of a glacier, this is where the bulk of the material carried by the ice ends up. However, renewed forward movement, so if the glacier decides to advance again, it will push this debris further downhill, rather like a bulldozer, and we call this process bulldozing. So, just to kind of sum up, it's really important that you understand the three processes of erosion in glacial areas: freeze-thaw weathering, abrasion, and plucking. It's also going to be important that you know about how glaciers move, so in terms of rotational slip, basal slip, and also internal deformation.